Good morning everyone, myself Shlok Keshwani and today I am here to teach you physics. In physics we will be learning about gravity and gravitational force. About gravity and gravitational force I have explained in my previous video part 1. This is the second part. Since the chapter is very long, third part video will also be made, which will be probably the last one. First topic, discovery. How was gravitational force discovered? Okay. First, it was discovered in 1666 when Newton saw an apple falling. He realized, when he saw an apple falling, he realized that there is a force, there is a force which attracts object. Okay. In a similar way, there is a force that attracts what? That attracts planet towards each other. Okay. Then he named this force as gravity. Means there is a force. There is a force which is performing two works. It is attracting object also. It is attracting planets also. Like this, it was discovered. Definition. Definition of gravity and gravitational force. It is the force of attraction. Force of attraction between any two objects. Force of attraction between any two objects is known as gravity and gravitational force. Okay. It is not one-sided. It is double-sided. For example, let's say this is one object, another object. You are applying a force on it. This will also apply force on it. It is not like that object 1 will only apply and object 2 will not. Both will apply. And of same. Okay, 10 Newton. For example, this is applied force of 10 Newton. This will also apply the force of 10 Newton only. It will not be like it is applying force of 10 Newton. Another one is applying force of 5 Newton. Okay. From this law, from this, you come to know, or you आपके दिमाग में चीज पॉप आउट होती होगी, जो कि है न्यूटन्स थर्ड ऑफ मोशन. न्यूटन्स थर्ड ऑफ मोशन स्टेट for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. मतलब आपने किसी पे ऑब्जेक्ट फोर्स लगाया तो बैठे नहीं रहेगा. किसी भी ऑब्जेक्ट पे हमने फोर्स लगाया, जैसे यहाँ पे ऑब्जेक्ट 1 ऑब्जेक्ट 2 पे फोर्स लगाया तो बैठे नहीं रहा, उसमें भी इक्वल और अपोजिट फोर्स लगाया. ठीक है. तो दिस इज ग्रेविटेशन. नाउ न्यूटन्स लॉ ऑफ ग्रेविटेशन. Newton made three law of motion. Okay. Newton's law of gravitation. Newton's law of gravitation is also known as fourth law of Newton. Fourth law of Newton. What does it state? Every object in the universe attracts each other. Okay. The distance. Every object in the universe attracts each other. Okay. By a force. That force is directly proportional to a distance, proportional to the product of their masses, and inversely proportional to the square of the distance between them. Okay, if not understood, let me explain once again. See properly. Every object in the universe, you take any object in the universe, attracts each other by a force, and that force is directly proportional to the object of their masses. That force is directly proportional to their masses, product of their masses, and the square of the distance between them is inversely proportional. Okay. Square of the distance between them is inversely proportional. Okay. Now, formula which you should remember for finding out force. That formula is C. Force F, sign of proportionality. This sign. Okay. This sign is called sign of proportionality. Proportionality का sign. How can you find? See, m1 means mass 1 into mass 2 upon radius square. Radius is a distance. This distance is known as radius. This distance is known as radius. Okay, understood. This sign of proportionality can be replaced by capital G. Capital G is universal gravitational constant. Okay. Now, the final formula made is F equals to G m1 m2 upon r ka square. Now, the derived unit, the unit of force is nm square upon kg square. Okay. If in MCQ it comes right, then you can directly take nm square upon kg square. But if in exam it comes to find out the derived unit, then how will you find? See, it is very easy. First, we will add the formula. F equals to G m1 m1 m2 upon what? What upon? What will be? F equals to G m1 upon m2 upon m1 into m2 upon radius square. F equals to, sorry, my bad, I spoke wrong, I think. I spoke m1 upon m2, but it will be F equals to G m1 into m2 upon r2 radius square. Okay. Okay. Radius square. Radius square. Radius square. m1 into m1 upon m1 into m2 upon radius square. Okay. Now, can we write it like this? See, F equals to G m1 into m2. Mass is always measured in kilogram. Mass is always measured in kilogram. Can we write it kg square, because two mass are there? Radius square, meter square is there. Again, square will be there. Okay. Now this formula is clear. Now wait. Before doing this step, can we denote it like this? N equals to G m1 n2 upon r square. Why n? N is the SI unit of force. Okay. Now, what can you do? N equals to G m1 m2 upon r square. Like this, you can make the bracket. The next step which you can do is what? See, I'm erasing this step. F equals to G m1 into m2 upon r square. Okay, this is directly changed into n, which is the SI unit of force, n. Now it will be G m1 into m2 upon r square. N equals to G m1 equals to G. Now mass is always measured in kilogram. So kilogram, two masses is square, radius is measured in meter, square is already there. Now this will go up, this will come down. Okay, what will happen? This meter square will go up to n. Okay, to n it will go up. This will come down. It will be what? N m square upon nm square upon kg square. Okay, what it will be? It will be what? Nm square upon kg square. Like this, you can find the derived unit of a force. Okay. Examples of gravity. What are the examples of gravity? See, it is the force that causes ball to come down. Yes, gravity. The force that keeps planet sorry, a force that keeps planet in orbit around the sun. Yes, gravity. A force that causes rock to roll downhill. Yes, here also gravity played a role. Importance of universal of gravitation. Universal of gravitation important. See, it is the force that binds us together. Which force is being talked about? Gravitational force. Gravitational force is being talked about. Gravitational force is being talked about here. Okay, gravitational force is being talked about here. Okay, it is being gravitational force we are talking here. Now, it is also responsible for the motion. Yes, motion of moon around earth. It is also responsible for motion of earth around sun. Okay, since moon also orbits around earth in the same way earth orbits around sun. Okay, it is gravity. Here also use of gravitational forces used. Now, it causes tides in sea due to moon. What are tides? See, whenever you would have visited a coastal area, you would have seen in books oceans. For example, this is ocean, है ना? ये ocean होगी, sea होगी आपकी. High tides means when the waves come up. Okay, low tide when they go like this. Okay, in a very flat manner. This you would have studied in geography or SST, high tide, low tide. Okay. Why is this caused? This is caused due to the gravity of moon. मून वहां बैठा बैठा कंट्रोल कर रहा है टाइड्स, है ना, मून वहां बैठा बैठा टाइड्स कंट्रोल कर रहा है, उसकी वजह से टाइड्स कॉज्ड हो रही है. ओके, अंडरस्टूड. इंपॉर्टेंस ऑफ यूनिवर्सल ऑफ ग्रेविटेशन. यूनिवर्सल ऑफ ग्रेविटेशन की इंपॉर्टेंस क्या है? ठीक है, this we have discussed. Universal of gravitation. Variation in the value of g. See, capital G is universal gravitational constant. Small g is used to denote acceleration due to gravity. Acceleration due to gravity. It is the change acceleration. See, acceleration's definition I have explained in my previous video. If you have not watched, watch it, and I am explaining in this video also. Acceleration is what? Acceleration is the change in velocity over a period of time. Okay. And how can you find acceleration? Acceleration equals to velocity, final velocity, minus velocity which is in the state of inertia upon time. Okay. Means simple formula to find acceleration is final velocity minus velocity which is inertia upon time. Like this you can find it. What? Acceleration. Okay, like this you can find acceleration. Altitude. As, see, G means acceleration due to gravity. Acceleration due to gravity decreases when you move away from the Earth's surface because the Earth's radius increases. Okay. Now, what you understood what is acceleration? What is acceleration due to gravity? See, for example, you are riding a bike and its speed changes over a period of time. It is an example of simple acceleration. But when you throw a ball upside and it came down, first its speed was let's say 4 meter per second, or let's say whatever. Okay, I will not give accurate, 4 meter per second, and while coming down it became 5 meter per, or let's say 8 meter per second. So here the use of gravity was there, because when it was coming from down, gravity, the surface was attracting it. So this was acceleration due to gravity. Okay. Normal acceleration is when you ride a bike and the speed of bike changes over a period of time. But when let's say an apple falls, its speed is 4 meter per second. But because of the force are getting and after coming down, its speed becomes 8 meter per second, or I think it will become less, 2 meter per second. Okay, I don't have any idea about this. So just there will be change. Okay, let's say it becomes 2 meter per second. I don't know, it will be more or less, but change will be there. So there is a change because of gravity. This is known as acceleration due to gravity. And as you move away from the Earth's surface, let's say, right now I explain you one formula. What was that formula? That formula was F equals to G M1 M2 upon R square. Okay, this was a simple formula. Radius. Here radius means distance. Radius का मतलब distance है. Let's say when your ball is brought near Earth, then it's, let's say this is Earth and the ball. When the ball will be here, or wait, the ball will be, let's say when the ball will be here, when the ball will be here, then gravitational force will be much, or when the ball will be, let's say Earth is this only, and when the ball will be there. Okay, इसका इतना डिस्टेंस है, इसका इतना डिस्टेंस है, तो रेडियस कितना है? रेडियस तो यहाँ से चलो फिक्स्ड पॉइंट है, यहाँ से इसका ज़्यादा, इसका थोड़ा कम है रेडियस, है ना, इसका थोड़ा कम रेडियस है ना. तो अब क्या होगा? अब जितना आपका डिस्टेंस कम होगा, यहाँ पे डिस्टेंस बहुत कम है, उसका ग्रेविटेशनल फोर्स बढ़ा. डिस्टेंस बढ़ गया तो ग्रेविटेशनल फोर्स कम होगा. तो यहीं पे बता रहा है, एज यू मूव अवे फ्रॉम द अर्थ सरफेस, बिकॉज द अर्थ रेडियस इंक्रीजेस. ओके, द acceleration due to gravity decreases as you move away from the Earth's surface. Because the Earth's radius increases. Earth's radius increases. Depth. Amount of acceleration due to gravity decreases as you move deeper into Earth because the Earth's mass decreases faster than its radius. Okay. Let's say this is the same Earth. This is the same Earth. This is the same Earth. Okay, and you move to its depth. उनकी depth में हम जाते हैं तो what happens the earth's mass, what happened, the amount of acceleration to gravity decreases. Why? As you move deeper into earth, because earth की mass उसके रेडियस से जल्दी डिक्रीज होती है, तो जैसे हम नीचे चले जाओगे अमाउंट ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी डिक्रीज होगा. ओके, लैटिट्यूड. Let's say this is earth. Now there are some imaginary lines on earth, okay, which some geologists and all made for their easy learning, okay, so that they can learn easily. Earth is here. Latitude are these horizontal lines, okay. Now highest, okay, the amount of acceleration to gravity is highest at the poles and lowest at the equator. Why? Because the earth is not a perfect sphere. It is not a perfect sphere. It bulges at the equator and flattens at the pole. Bulges means like this in the pole, okay, and flat at the pole. Pole से flat है, यहाँ पे bulges है, ठीक है. Making radius larger at equator. Equator पे radius ज़्यादा होता है. अब जहाँ पे radius increase होगा वहाँ पे amount of acceleration due to gravity decrease हो जाएगा. तो ऐसे ही आप याद रखिएगा. You should remember like this that see, radius is larger in equator, okay, radius is larger equator, so gravity, acceleration due to gravity will also decrease, okay, because as the distance increases, acceleration due to gravity also it decreases. If it will increase, then if radius will increase, then acceleration due to gravity will decrease. That's why the acceleration due to gravity is highest at the poles and lowest at the equator, okay. Why? Because earth bulges at the equator and flattens at the pole, making radius larger at the equator. Radius is larger at the equator. That's why acceleration due to gravity also decreases. Centripetal force. About this force I had explained in my previous video, but not in a very detailed manner, so I am explaining it right now. See, definition and function. What is definition? A centripetal force acts towards the center and is required for an object to move in circle. Yes, it acts in a circle. As the name suggests, centripetal means it acts towards the center and it is required for an object to move in circle. It ensures circular motion and prevents an object from moving in a straight line. Okay. Circular motion. Circular motion involves a constant change in direction, okay, which alerts velocity. Examples: a stone tied to a thread moves in circle due to central part. For example, this. Don't judge the drawing. And stone is tied. It will move in circular direction. As you will throw. जैसे आप इसको छोड़ देंगे. Let's say यहाँ से आपने इसको थ्रो कर दिया. यू थ्रू इट, उसका छोड़ दिया, तब वो एकदम सीधी डायरेक्शन में चला जाएगा, ओके, एकदम सीधी डायरेक्शन में चला जाएगा, ठीक है. अब अर्थ ग्रेविटी प्रोवाइड सेंट्रिपिटल फोर्स टू मून्स ऑर्बिट. यस, gravity is also applied, but specifically in gravity centripetal force is applied, okay, which helps to moon orbit around earth. This is earth, this is moon. Why they orbit in a fixed circular path? Because of centripetal force. Centripetal force की वजह से they orbit in a fixed orbit. Acceleration due to gravity. यहाँ मैंने बहुत टर्म सुना acceleration due to gravity, acceleration due to gravity. इसमें फॉर्मूलाज क्या क्या है? देखो, सबसे पहले according to Newton's law of gravitation, capital G is used to denote gravitational constant. Now, capital M, mass of the earth. Why I am telling you this? Because now many formulas will be formed. Many formulas will be formed based on the small and capital GMR. So then you will get confused. G stands for which, small g and this. Okay. So for you to not get confused, I have written this. M, capital M, mass of the earth. Okay. Small m, mass of object. R, earth's radius. Okay. R for radius. Radius of earth means distance of earth from a fixed point. This is earth, fixed point. It is not completely earth, but yes, R a figure. Okay. Distance from this point to this point can be defined as radius. G, acceleration due to gravity. Right now I told you that small g is unit for acceleration due to gravity. It decreases as the radius increases. Radius if it will increase, then acceleration due to gravity will decrease. Now F stands for, now formulas are formed. Force equals to capital G. Capital G means gravitational constant. Okay. F equals to gravitational constant into mass of earth into mass of object upon radius square. Radius ka square means earth's radius square. Okay, you need to learn this formula. The force of an object due to gravity. Now the formula for getting force of an object due to gravity is F. F equals to M. M means mass of earth into acceleration due to gravity. Mass of earth into acceleration due to gravity. Okay. The force of an object due to gravity is force equals to mass of earth into acceleration due to gravity. Mass of earth into acceleration due to gravity. Okay. Equating force को equating करना is mg इक्वल्स टू जी. देखो यहाँ फॉर्मूला दिया गया है एम इंटू जी. स्मॉल एम क्या डोनेट करता है, क्या करता है स्मॉल एम क्या करता है, जल्दी से बताओ. स्मॉल एम मास ऑफ एन ऑब्जेक्ट इंटू एक्सेलरेशन ड्यू टू ग्रेविटी इक्वल्स टू कैपिटल जी इज यूनिवर्सल ग्रेविटेशनल कांस्टेंट into mass of earth, okay, into again mass of an object upon radius square. And when it is simplified, you get this simple formula, which is what? Acceleration due to gravity, G, acceleration due to gravity. After simplification you get what acceleration due to gravity, okay. GM means G, universal gravitational constant into mass of earth upon radius का square. Now there are some practice questions. Okay, practice questions. An object has a mass of 10 kg. What is its weight on earth and on moon? Okay, first understand this question properly. If you have seen my part 1 videos, you know that there were some numericals which were not of the topics which I taught in the previous video. They were the topic of this part. Sorry, they were the topic of the topics which are to be covered in this, covered in this video. So first numerical states that an object has a mass of 10 kg. Okay. Now what is its weight on moon and on earth? Okay, सबसे पहले weights formula weight is m into g. Okay, here mass is 10 kg. Right now we are finding of earth. Okay, we are finding of earth. Mass is 10 kg into gravity. Now you have to remember that gravity of earth is 9.8 meter per second square. Okay, if you will not have units, your answer will be wrong. Okay, this equals to this, after doing multiplication on 98 Newton. Okay. Now moon की क्या होगी देखो. सी ऑब्जेक्ट है मास ऑफ 10 kg. ठीक है. अब यहाँ से जब 9.98 न्यूटन रिवर्स पे निकला था क्या करेंगे 1.6 इंटू क्या कर देंगे 98 न्यूटन विच विल बी 16.3 न्यूटन. 16.3 न्यूटन. ओके. दिस विल बी द ग्रेविटी. No. Okay. Like this 1/6 into 98 Newton, which is here. After multiplying this, we will get 16.3 Newton. 16.3 Newton. Okay. Now, second question. What is free fall? What is free fall? And do objects have different rate? Okay. Do object. देखो, what is free fall? Now, this question is also divided into two parts. What is free fall? एंड टू ऑब्जेक्ट ऑफ डिफरेंट मासेस फॉर एट द सेम रेट इन वैक्यूम. मतलब ये क्वेश्चन कह रहा है कि सबसे पहले तो आपको डेफिनेशन स्टेट करनी फ्री फॉल की, और डिफरेंट मास के ऑब्जेक्ट स्पेस में यानी वैक्यूम में क्या सेम रेट पर गिरेंगे. तो सबसे पहले फ्री फॉल इज अ स्टेट व्हेन ग्रेविटी इज द ओनली फोर्स. ग्रेविटी इज द ओनली फोर्स. Force acting on an object. Okay, it is the state when gravity is the only force acting on an object. Okay. Understood? Okay, in this state gravity is the only force which is acting on an object. There is not any sort of force. Okay, इसके अलावा कोई force है नहीं जो object पे act कर रहा हो. Okay, at this time only gravity is the force which acts on an object. Now, what is the rest part of question? Do objects of different mass fall at the same rate in vacuum? So, in a vacuum which has no air resistance, a feather. Now, here we have taken example of feather. Okay, feather and a brick. Okay, and a brick. You can take any example of, let's say, lightweight or object which contains weight, more weight as compared to light object. Feather and brick, they fall at the same rate because gravity due to acceleration equals to gm, yani gravitational constant into mass of earth upon radius square. Okay, they fall at the same rate. Why? Because right now I have told you what, that gravity due to acceleration, there is a glitch. Gravity due to acceleration equals to universal constant of gravitation into mass of earth upon radius square. Okay, so it does not depend on mass of the falling object. Okay, so they fall at the same rate. Okay, they fall at the same rate. Okay, in a vacuum which has no air resistance, a feather and a brick, they fall at the same rate. Why? Because because of this formula which states that it does not depend on the mass of the falling object. Okay, free fall does not depend on the mass of the falling object. Okay, this will be question third, but by mistake I have written here question 6. See what it will be question third. Okay, question third यहाँ पे हो जाएगा. Question third. See, what happens to a force between two objects if their distance is doubled? Okay, so distance formula is 1 proportionality, sign of proportionality into 1 upon. Okay, no, sorry, it will be force, the sign of proportion, my bad. Let me write it again. So force, the sign of proportionality will be used, 1 upon denominator square. Okay, distance. Okay, now see, 1 by distance square है, so it will be force equals to 1 by 2. Okay, 1 by 2 का square हो जाएगा. Now this, see here it was 1 proportionality 1 upon d square. Okay, now since the distance, this d, wait, it was not for denominator, sorry, it was for a distance. Okay, sorry, my bad. F proportionality 1 upon distance square. Ab distance is doubled, means 2 times. So first it was 1 upon 2 square. Now it will be 1 upon 4. 1 upon 2 ka square, 1 upon 4. This will be your final answer. Okay. 1 upon 4 square will be your final answer. Okay. So what happens to the force between two objects if the distance is double? So F proportionality 1 upon distance square, which is 1 upon 2 square, which is 1 upon 4. So like this change will occur to a force when the distance between two objects is doubled. Okay. Now I hope this topic of gravity and gravitational force is clear to you. Since this topic is very long, part 3 video will come soon. Till then revise from textbook, practice numericals, because only by seeing video you can't get, you have to practice also. Okay. So bye. Don't forget to like and subscribe, and also practice numericals and learn from you. Okay, bye.